This is Geometry Chapter 7 review for the final. Follow along with me and go as we go. Alright, so your detailed objectives and we go down the page. So the objective for these problems is that students will be able to write ratios and solve proportions. So this entire page is all about that. The first question says, in a perfect milkshake, the ratio of ice cream to milk is 2 to 3. You need to make 2 parts ice cream, you should have 3 parts of milk. For a school event, you need a total of 65 cups of milkshake. How many cups of ice cream do you use? Well, you can first think about one milkshake. One milkshake is going to be 2 parts ice cream plus 3 parts milk for a total of 5 cups of milkshake. If you're going to make it for 2 people, you need double the amount. You need 4 cups of ice cream plus 6 cups of milk, and that's going to give you a total of 10 cups of milkshake. And so if you think about it, even for a third person, we're going to triple the original amount. 6 cups of ice cream plus 9 cups of milk gives us a total of 17 cups of ice cream. And so what we're doing each time is we're taking our parts of ice cream and our parts of milk, we're multiplying both of them by the same factor, and adding them together, and together it's giving us our total amount. So if our total amount is 65 cups of milkshake, that's going to equal 65. Now when we solve for x, it won't give us the amount of ice cream we use, but it'll give us the amount of servings that we're actually making. So we combine our like terms, 2x plus 3x gives us 5x equals 65. Divide both sides by 5, and x equals 13. So we're making 13 servings of milkshake. Now what we want to do is we want to take that 13 and multiply it by the amount of ice cream that is in one serving. Well, there are 2 cups of ice cream in one serving, so we're going to go 2 times 13. That gives us a total of 26 cups of ice cream. And so that's our first part of setting up to find, using a ratio to help us find total value. This next one says the extended ratio of the length of the sides of a triangle is 3 to 4 to 5. The perimeter of the triangle is 48 inches. How long is the longest side? What they're saying is if you have a triangle like this, if you have a side of 3, 4, and 5, that would be a very small triangle. That would be a triangle with a perimeter of 3 plus 4 plus 5, that'd be a perimeter of 12. But we have a perimeter of 48. And so just like the last problem, we're really doing for taking each one of these factors and we're multiplying it by the same thing. Remember, the perimeter is the total distance around. We're going to move 3x plus 4x plus 5x is 48. Combine our like terms, 3x plus 4x plus 5x gives us 12x equals 48. Now divide both sides by 12, and we get x equals 4. Now, that is not the length of the longest side, that is the amount that we're multiplying each one of these pieces of our ratio by. So if we look at the longest side, well, multiplying by 3 is going to give us 12. Multiplying by 4 is going to give us 16. Multiplying by 5 is going to give us 20. So the longest side is 20 inches. All right, here is our last problem. It says on this page. It says, what is the solution of the proportion? When we solve proportions, remember, we do is we cross multiply. We multiply the top left by the bottom right, and the bottom left by the top right. So 5 times 12 equals 8 times f. Now we start to simplify this. We go, oh, what is 5 times 12? That gives us 60. 60 equals 8f. Divide both sides by 8, and we get f equals 7.5. Sometimes when you have a proportion that you solve, you could have a variable up here multiple times. Remember that we can have quadratics and we can solve it things like that. We want to use a quadratic formula or factor to help solve for that purpose. All right, here's the second objective. It says students will be able to use the angle postulate and the side angle side and side theorems. We talked about these similar theorems that were about congruence, so these ones are just about similarity. Remember, similar means that you have one object that's smaller and one object that's larger, but all their angles are congruent and their sides are proportional. And so this one says, are the triangles similar? How do you know? What we want to do is we want to actually just check these angles to start with. So each of these triangles has two angles, and so we can use the fact that all the angles of a triangle should have 180 to find the third angle. So we take 180 minus 56 minus 14, we get an angle to be 110. So that top angle is 100 degrees. Do the same thing on the next one. You go 180 minus 56 minus 20, and we get that angle to be 104 degrees. Now, you actually probably didn't even need to calculate the third angle in this triangle right here, because you might notice right off the bat that these both have one congruent angle, 56 and 56. But once you got the 110 and the 14 degrees in the first triangle, you notice that neither of those are the same as 20, which means that, well, even it's not possible for these triangles to be similar. So are they similar? No. Our reasoning why being they only have one pair of congruent angles. You need to have three pairs of congruent angles to be similar. Let's move on to the next one. It says, are the triangles similar? How do you know? We have one called side angle side similarity. And so what it means is that they have two sides that are proportional and the angle between them are congruent. So I always check the angle right off the bat. 32 and 32, hey, that part's good. Now I want to check the sides and see if the sides are proportional. So we can kind of see how they're lined up. 25 and 15 look to be the longest sides, so let's check what is 15 divided by 25. 15 divided by 25, we should get that to be the same as 3/5. Now when we set up the next ratio, we want it to simplify to the exact same thing. So we go 10.8 over 18. Use your calculator to help you on that one. If you're stuck with those decimals, go 10.8 divided by 18. You should get 0.6. And if you remember how to use your math frac button, it will turn that into a fraction for you. You should get that also to be 3/5. That means that their sides have the same ratio. They have the same ratio, they're proportional. So those sides are also similar then. Are they similar? Yes. The reason why, because of side angle side similarity. Make sure you're copying this down with me in your notes. I know I'm going quickly. Feel free to pause the video if you need to. So here's this next one that says, are the triangles similar? How do you know? Well, we have side angle side, we have side side side, and we have angle angle postulate. So if we look up here, I always look for angles to start with. I see two right angles. That's a good sign. And so if we want to check for side angle side similarity now, we want to set up those sides that are corresponding. Now both of these triangles have 3 side lengths, all your side lengths given. So if you set up the longest ones attached to that right angle, the 12 and the 8, see what that ratio simplifies, 8/12. That's the same as saying 2/3. Now we want to check the other pair of sides that correspond. That would be your 6 and your 5. Well, 6/5 doesn't simplify anymore. Notice 2/3 is not equal to 6/5. That means that these two triangles are not proportional. They are not similar triangles. How do we know their corresponding sides are not proportional? Let me change that word. Their corresponding sides are not proportional. That was the second learning objective. You got 3 more learning objectives to go. So, stick with me on this. Here's the next one that says, students will be able to use similarity to find indirect measurement. Indirect measurement is when you have a situation where you can't figure out maybe how tall something is or how far away it is, and so you use trig to help you out, or you can use proportions to help you set up corresponding parts and find these measurements. So it says a man is trying to measure the height of a tree. He placed a mirror on the ground 52 feet away and backed up until he could see the tree in the mirror. So his mirror is right here. right? His eyes are 6 feet above the ground, and he is 10 feet from the mirror. How tall is the tree? Well, what happens when you back away like this is you actually result in two congruent angles right there. And so, if we're looking at this, we have a right angle over here with the tree with the ground. If we bring that distance down from their eyes, it also makes a right angle with the ground. And if two objects have two pairs of congruent angles, then they are similar, meaning these two triangles are now similar that we're creating. And if they are similar, their sides are proportional. And so we can take these, let's say this tree is X feet tall, and we're going to set up the proportional parts. I notice that the person is 10 feet from the mirror, and the tree is 52 feet from the mirror. If you look at those angles made by the endpoints of those two segments, those are corresponding. They both have a right angle and that one congruent angle. So we can set those up as a ratio, 52 to 10. Then, if you look at the height of the person, 6 feet, and the height of the tree, X, those are also our corresponding sides because they're the other pairs of legs. So since we went tree to person, we have to go tree to person as well. Tree height to person height. Now we're ready to use our cross products to solve and find X. We're going to go 52 times 6 equals 10X. We're going to know what is 52 times 6. 312 equals 10x. We divide both sides by 10. We get x equals 31.2. This tree is 31.2 feet tall. And that's what we can use indirect measurement to help us solve. All right, just a few problems left to go and we'll be done with this video. So, here we go. So students will be able to find and use relationships in similar triangles. When we talked about this, we also talked about geometric mean. And that might seem like a random concept to have in the middle of this triangle objective, but it actually goes along with it. Geometric mean means there's some number where you can say that 5 divided by x equals x divided by 45. Remember, we had means and extremes. So in this situation, x and x would be your means, and 5 and 45 would be your extremes. And so, in order to solve this one, what you're going to do is you're going to take your cross products and you're going to multiply them. 5 times 45 equals x squared. And this is always true. If you're trying to find the geometric mean of two numbers, it's the product of two numbers equals the geometric mean squared. And so we're going to go 5 times 45, that'll give us 225 equals x squared. And now we take the square root of both sides. X equals 15. The geometric mean of the pair of numbers 5 and 45 is 15. So when we set up this next one, it says, if 16 and x have a geometric mean of 24, what is x? When I set this up, I usually skip ahead to that second line that we had. Two numbers that have a geometric mean, 16 and x. So 16 times x equal the product of the two extremes equals the square of the mean. The mean is 24. 16 times x equals 24 squared. Now we just want to start solving. So we'll do 24 squared first for the order of operations. That gives us 576 equals 16 times x. Divide both sides by 16. And we get x to be 36. So 16 and 36 have a geometric mean of 24. All right, here's a triangle problem. It says triangle ABC is similar to triangle DEF. Remember that little squiggle means is similar to. Find all missing sides in the triangles. And so there's a few ways you can go about this. If your triangles have angles, you can line up the corresponding parts. But if they give you a similarity statement, then you can use that to line up your corresponding parts by looking at the orders. It means that A, B, the first two letters correspond to the first two letters in D, E, F. That would be D, E. So A, B, and D, E go together. B, C should go with E, F, because those are the second and the third letters. Don't forget to set up your ratio of the last to the first. CA is going to equal D. So let's just start to write out some of these ratios. A, B, that's 17.6 to DE. We don't know what DE is at this moment, let's just call it X. So that ratio is 17.6 to X. Now we go to BC and F. BC, we don't know. Let's call it a different variable than X, because those sides shouldn't be the same length. Let's call it Y. It corresponds to EF. EF is 5.8. Now we'll do CA to FD. We know CA, that's 17.2. FD is 4.3. Now, this is really helpful. That's 17.2 and 4.3. Those are two sides that correspond, and we know the measurements of both of them. So what we want to do now is we want to take that ratio and we want to simplify it. So this is where your calculator comes in really handy. If you type in 17.2 divided by 4.3, you end up getting that it simplifies to 4. And then you want to write a ratio as a fraction. So you would say that it's 4 over 1. Now, that means that the scale factor is 4 to 1 or 1 to 4, however you want to think about it. The larger triangle ABC is 4 times the smaller triangle DEF. And so you can actually start to use that to set up some proportions to find the missing side lengths. Because the corresponding sides AB and DE, that's 17.6 to X, that should also simplify to 4 to 1. So now we can cross multiply and solve and get 4x equals 17.6. Divide both sides by 4, and we get x equals 4.4. So that means that DE equals 4.4. Now what we're looking for is BC, so we can take that ratio, y to 5.8, and set that one also equal to 4 to 1. Cross multiply and solve. We get y equals 4 times 5.8, and y equals 23.2. So y is talking about BC. BC equals 23.2. Now, the one thing you need to make sure is that if there are labels in the problem, your answer should have labels as well. Both of these say inches for their labels, so you should have inches and inches. And there will be your final answers. Now, notice that I may have used x and y as placeholders in the problem, but when I stated my answer, I went back to say that those aren't x and y, those are D, E, and BC. I put x and y in there. To a grader or another person, x and y might not make as much sense, whereas DC and DE and BC are very specific and you should know what those mean. We're on to our very last page, so here we go. The objective is that students will be able to use the side splitter theorem and the triangle angle bisector theorem. The side splitter theorem and the triangle angle bisector theorem basically say that, hey, if you have two parallel lines, like in this problem, you have two parallel lines that make up some triangles up there, the sides that they cut are proportional. And so we can actually set up a ratio, a proportion of the sides that are cut up. And so if you look, they give you, on the left side, they give you a segment of x inches and a segment of 5 inches. On the right side, you have a segment of 7 inches, and the entire thing is 15 inches. You want to use that 15 to find the other little segment. Shoot whatever 15 minus that 7 is, hey, that's 8 inches. Now what we can do if we solve this one is set up the corresponding parts to each other. We can say x to 5, those two parts that are cut up, should equal 7 to 8. Now notice, you can set up a proportion many different ways. I have it lined up, portions are lined up 2 different ways. You can have 2 parts from the same shape on top of each other, so x to 5 is 7 to 8. But then if you look across, x and, oh, I set up the second one wrong. Let me fix that. It shouldn't be 7 to 8. It should be 8 to 7. And the reason why it should be 8 to 7 is x is the bottom chunk and so is 8. 5 is the top chunk and so is 7. And so the same ones are vertical, but the parts from the same side are vertical, but they're corresponding parts are horizontal. So you can set them up many different ways. What really matters is that you get the same cross products as I do. 7x equals 40. That's the cross product you should have. Once you get that, you can divide by 7, and x equals 47. You can leave your answer like that. That is in simplest form. If you decide to put that as a decimal, you should get it to be about 5.714. Since they really didn't tell you to round 47ths, that's going to be your most accurate answer you can do this way. Here is our last question for today. It's the same type of concept. The side-squared theorem, even if we don't have a triangle, we have 3 parallel lines here. We know that from these 3 parallel symbols. That means we can set up the corresponding parts, and we can write proportions just like we did up above. Let's say 3x to 15 is going to equal 6 to 10. Cross multiply, solve, 30x equals 90. Divide both sides by 30, and x equals 3. They didn't give us any labels or any units, so we can just leave it at x equals 3. Also, it's not a side length, 3x is a side length, so x equals 3 is an acceptable answer. That was really fast. Feel free to go back through and rewatch some of the problems if you need to. Try them on your own. But this is the end of the Chapter 7 for Geometry for